So your pivot, and this is a point where the force is being applied, and the distance between these two is 6.0 meters. That's part of the question. But this distance is not perpendicular to the force. You see, these two are not perpendicular to each other. How do we solve this? Two methods. Let's go with both of them. So method number one, which is the method of drawing the components. And sometimes they strictly ask you, like I told you previously, they can ask you strictly use the method of components to find the moment of force. So either F or the distance, either of these two have to be resolved into components. You can resolve distance into components or force into components. Which one is better to resolve? I think the one that is already horizontal or vertical, you should leave that for as it is, and the one that is slightly bent, slightly tilted, should be resolved. So I'm going to resolve this force into two components. So the force is towards top left corner. So one of the component would be upward, vertically upward, and the other component could be towards the left side. So I wanted to draw one component that is perpendicular to the distance, and then the other component would be perpendicular to the first component. So let's say these are the two components. Right, so these are the two components for the force. Out of these two components, which component is perpendicular to the distance? Is it the one to the left or is it one upward? So in this case, the component that is upward is perpendicular to the distance. So this component is perpendicular to the distance. Component in this direction, distance in this direction, only then we can get an angle of 90 degrees. Up next, if this is a component that is perpendicular to the distance, what is the value of this component? So this component is not touching the angle directly, so mathematically it would be 200 times sine 50. Why sine 50? Because it's not touching the angle directly. And I don't even need to write the expression for the second one, because I don't even need it for the moment of force. So turning a vector force equals to force. Let me write down the expression first. Force times the perpendicular distance, and then we have force 200. What is the perpendicular distance? Sorry, the force is 200 sine 50. This is the perpendicular component force times the distance 6. And if we write it on the calculator as it is, could you tell me what do we get? Shouldn't be with the negative sign. Sine 50 is non-negative. Make sure you close the brackets after 50. Otherwise, on calculator, times 6 would also be part of the angle. Yes, 919, or into SF you can write it as 920 Newton meter. That's the first method. Then we have the second method also. which is to directly use the formula. So the formula is you have to use f d sine theta, but I'm going to be very careful with the angle, because if you use the formula directly, you got to be very careful with the angle, with this thing, with the angle. When you use the expression f d sine theta, the angle is the angle between the force and the distance. So the angle between the given force, not the components. The components are not even there. This is the second method. And matter of fact, I should even raise the components. So for this method, all you have is the force and the distance. And this is the distance. So is this angle 50? Is this angle between the force and the distance? And the answer to that is yes. This angle is between the force and the distance. We can see it for ourselves. The angle is between the force and the distance directly. Over here. So theta is directly between force and distance, so we can use the value of theta as it is. We don't have to subtract it from 90 or anything. So force 200, distance 6 times sine of the given angle, because the angle was directly between force and distance. So you get 919 point something, but in 2SF you'll be getting 920 Newton.